I feed birds during the winter time, so it occurred to me that I should perform an experiment with a bird feeder. And today, while watching chickadees harvesting black oil sunflower seeds from my backyard feeder, I thought, I should do a food preference study using two types of sunflower seeds, the black oil seed and the white stripe seed. I'd been feeding the black oil seed for weeks now, and this was obtained from our local Hugo's grocery store. And today I purchased the white stripe seed from Home of Economy. The white stripe seed comes from the Performance Seed Company in St. Cloud, Minnesota, and is sold under the name of Nature's Beauty. The white striped and black oil seeds appear to be not only different in color, but different in size as well. See Figure 1. And so I counted 5 lots of 100 seeds for each of both types of seeds and determined the mass per 100 seeds and volume using a graduated cylinder for all 10 lots of 100 seeds. See Table 1. The seeds were massed using a pan balance, the Ohlhaus scale, to the nearest 1/10 of a gram, and the volume was estimated to the nearest milliliter using the graduated cylinder. See Figures 2 and 3. Figure 4 shows all 10 lots of 100 seeds, 500 for black oil and 500 for white stripe seeds. I did a little internet research to learn more about sunflower seeds and seed preferences for different bird species. According to the Wild Bird Feeding Industry Preference Chart, chickadees prefer black oil seeds to white stripe seeds, and this pattern held for nuthatches too, but not for sparrows, which appear to eat both black oil and white stripe seeds without preference for one or the other. Table 1 here shows the mass in grams and volume in milliliters of the 10 100 seed samples of sunflower seeds that I determined the mass and volume of. Note the summary statistics here, the X bar or mean, the standard deviation or variation, and the measure of variation, and the N, which is the sample size. Of special interest was an online article by Elrod D. Geese of the U.S. Fish and Wildlife Service, and his study of feeding preferences in birds is much discussed online, and I printed the article for closer study and reference. Data in Table 1 shows that the black oil seeds are on average 18.8% smaller by weight and 27.8% smaller by volume. This is important to note, I think. There also appears to be greater variation in the volume for the white stripe seeds than for the black oil seeds. But this is only a preliminary observation or anecdotal observation, because I've not actually quantified the exact volume for samples of individual black oil and white stripe seeds. My plan is to mix 500 black oil and 500 white stripe seeds into a bird feeder tomorrow morning before the birds arrive to feed. I will empty the screen tray and then fill it up, and the birds will have access to only the 1,000 seeds that I place into the feeder. I will let the birds feed until approximately 1/2 or more of the seeds are eaten. And this will be difficult to determine, but I don't want the birds to eat all the seeds, because then I wouldn't be able to determine if they have a preference for one seed type or the other. Tomorrow's low temperature is estimated to be near minus 20 degrees Fahrenheit, so I imagine that the birds at the feeder will be eager for food, having spent the night in a cold and windy environment. I put the feeder out at 7:20 this morning, and the temperature was minus 17. The feeder was fastened to the deck railing, so it was approximately 1 meter above the surface of the snow. See Figure 5 for a photo of the feeder with all of the seeds in it. I keep a record here beginning at 7:55 when the first birds arrive, and the conclusion of the experiment at 10:33. At the beginning, juncos and chickadees were the first to arrive. At 7:59, I had to remove the wire mesh from the feeder because I observed that the chickadees were having a hard time reaching the seeds through that wire mesh. By 8:05, I could see the chickadees were in fact beginning to eat. The first of the house sparrows arrive in a flock after the juncos and chickadees in mass, and then a downy woodpecker comes and feeds for a while. And so there's lots of activity at the feeder, and I decide to end the experiment at 10:33. And I'm guessing about half the seeds are gone. It's hard to tell till I open the feeder. I arranged the seeds into groups of 10 seeds sorted by type, black oil and white striped seeds, and then photographed the array, and you can see that here on figure 6. It's a very bad cell camera photo. It is clear that the black oil seeds were favored by the chickadees and house sparrows in this experiment, and those are the two dominant species to visit the tray. 70% of the black oil seeds were eaten and 20% of the white striped seeds were eaten. The birds in the experiment favored the black oil seeds over the white striped seeds by a factor of about 3.47 to 1. That is to say, for every 10 seeds selected, 7.8 were black oil and 2.2 were white striped seeds. These data corroborate the findings of the earlier study by Alred Geese. The black oil sunflower seeds are favorited by chickadees. That I saw without a doubt. That most of the seeds were eaten by house sparrows in my study was of interest because house sparrows apparently do not discriminate according to the literature. Table 2 shows the number and percent of black oil and white striped sunflower seeds at the start and end of this experiment, and by subtraction I could calculate the number of seeds eaten by both types on the morning of the 18th of January 2011 when the temperature was quite cold. Thoughts. The seeds are similar in size and shape, but the black oil seeds are a bit smaller and heavier, as we see in Table 1. But it does not appear that when given the choice of taking a larger sunflower seed, that the birds in this study took any advantage of that. They clearly preferred the black oil seed by a strong margin of 3.5 to 1. The birds and most of the seeds were eaten. The birds in this study and most of the seeds that were eaten in this study were by house sparrows, and clearly they were able to discriminate between black oil and white striped seeds. Could this be because these birds have been habituated to the black oil seeds? This was the first time, to my knowledge, that the birds in my backyard had been introduced to the white striped seeds. So I've been feeding a mixture of millet and black oil seeds for the past several weeks. Suggestions for further study. Would it be possible to effectively color in a harmless way the black oil seeds so that I could see if the birds identified or distinguished black oil from white striped seeds by sight? I have in mind scraping the seed hulls of a sample of black oil seeds so that they more closely resemble the white striped seeds, and then repeating this experiment with large samples, treated and untreated seeds. This is the study by Geese that I referred to.